All right, so we're moving on to geometric sequences. So as a reminder, we've already done arithmetic sequences, and an arithmetic sequence has a common difference. So to get each next term, you would add something or subtract, like add a negative number, right? So like plus 2, plus 2, plus 2, plus 2, plus 2, or minus 5, minus 5, minus 5, minus 5, minus 5. A geometric sequence does not have that pattern. So here's the definition of a geometric sequence: a sequence in which the ratio between successive terms is constant. So it's the ratio between successive terms. The constant is referred to as the common ratio. So it's not a common difference, it's a common ratio, okay? So right here it says determine if, some of these are easy to see and you're like, yeah, I see what the common ratio is. I know how to, what to multiply by to get the next term. But then some are more difficult to see than others, and I'm going to show you how we can find them slightly easier. Okay, so it says determine the common ratio and find the next three terms of each geometric sequence. Okay, so I want to know what I multiply a term by to get the next term, right? So what do I multiply? I just turned my, there it is. What do I multiply 4 by to get it to be -8, which is -2? And then that needs to continue in order for it to be geometric, which it does. All right, so this one's easy to see. And then continue to multiply by -2 to get the next three terms. So -32 times -2 is 64. Whoa, that's never happened with this pen. Is 64. I swear, I'm fine. And then times -2 is -128. Times -2 is 200. Watch out, girl. 256. What's going on with my pen? That's better. And then times -2 is -512. Okay, and yes, you can use a calculator for that. I was having a little brain freeze with it, but I was able to do it still. But if you need a calculator for it, you can use it. So, speaking of using a calculator, I should get mine ready. It's not ready at all. I should get it ready for when this, because ratios, you're definitely going to need it. Redirecting where? Let's go to Google Panther Hour lesson. Oh man, I think I'm gonna start this video over because I don't feel like dealing with this right now. How do I find my bookmarks? You think I'm gonna, no, just fast forward through this, me talking to myself, please. Okay, there's my calculator. I'm back. I don't have to start over. Okay, so let's say I didn't know what -32 times -2 was, right? I could do -32 times -2. I get my 64, and then I definitely don't know what that times -2 is if I didn't know the other one, right? Enter. Okay, so notice I just hit times -2, and now I can just continue to hit enter, and it'll keep giving me the answers. Isn't that beautiful? Okay. All right, here's the next one. What do I multiply 3 by to get it to be a 9? And that's 3, so times 3. This is times 3 times 3. And I'm writing it 4 times because I'm checking it each time to make sure that it's like, oops, nope, that one's +1. Okay, so now I need my calculator for this, or I want my calculator for this. 243 times 3, enter. Oh, so R is 3. Should write that down. And then 729 is next. Oh my goodness. It's the tip, it's broken on this. Oh no. I'll survive. 729. And then I'm gonna hit times 3, enter. 2187. And then I can just keep hitting enter. Enter 6561. Enter 19683. And notice I'm not putting a a comma in my 19683 because then it's going to look like it's a term, like 19 is a term and 683 is a term. Key. All right. Now I have the next one. What do I multiply a 4 by to get it to be 11? And that's where people are like, some are like, yeah, I know. And then some people are like, what? I don't know. It's a decimal, right? So let's go back to the other two. Like if I didn't know what I multiply 3 by to get it to be a 9, I can go vice versa. Like I can go backwards. I can say, okay, what's 9 divided by 3, which is 3? What's 27 divided by 9, which is 3? What's 81 divided by 27, which is 3? So what you could do is you could take this term and divide it by this, right? Your second term and divide it by your first term. So that is 11/4. So I would multiply by 11/4 to get 11, right? So 4 times 11/4 is 11, makes sense, right? Times 11/4 times 11/4, right? So I'm going to keep multiplying by 11/4. So I'm going to do 83.1875 times, and you can do 11/4 or you can do 2.75. Yeah, 2.75. So either one. So I'm going to say R is 11/4 or R is 2.75. If it was like 1/3, I'm not putting 0.3 repeating, I'm putting 1/3, right? All right, so the next three terms I'm going to do times 2.75 or times 11/4. Oh, today better start going better. Second enter, go back, change that to a 5. Okay, so we have 228.765625 times 2.75, enter, is 629.1054688, enter, 1730.040039, enter, 4757.610107. Okay, you might be asking yourself, do we have to write down all those numbers? Can we just like round? Yes. If this is an irrational number, you can, or a number that just doesn't fit on the calculator screen is what I should say, you can round to 3 decimal places. Otherwise, you can write down all the numbers on the screen. Another thing you can do is you can choose to turn it into a fraction. So if I hit math and then I go to the first option, which is fraction, and hit enter, it should turn it into a fraction unless it doesn't even fit on the screen. But like, for example, if I had 2.75 instead, 2.75, right? And I want to turn that into a fraction. If I hit math, please turn this into a fraction. It'll tell me it's 11/4. Okay, that was a long explanation for the easiest part of this whole lesson. Okay, well, okay, maybe. All right, so that was time consuming. The rest of these aren't very time consuming. So now we're going to learn how to write an explicit rule or an explicit formula for, for a geometric sequence. So in order to write a rule, you're going to need 2 things. You're going to need the ratio, the common multiplier, and you're going to need the first term because that's what's in the formula. Once you have that, you can write your rule. It's a sub n, which is, the nth term is equal to a sub 1, which is the first term, times r to the n minus 1. Okay, so let's go ahead and do some examples here. So now that we know both geometric sequences and arithmetic sequences, we have to always check to make sure that it's geometric or make sure that it's arithmetic and not just assume. Excuse me, I have a drink so that tickle in my throat goes away. All right, so I have to check to see if this is arithmetic or geometric. We're going to check for geometric first just because that's the section that we're in. So what do I multiply 12.5 by to get a 5? I don't know off the top of my head. So I'm going to do 5 divided by 12.5. That is ugly. So I'm going to do 5 divided by 12.5. And I get 0.4. And then I'm going to do math, enter, enter. And then I'm going to see that it's 2/5. So I multiply by 2/5 to get the next term. So 5 times 2/5 is 2. 2 times 2/5 is 0.8 times 2/5. Oh my God. Oh, it looks like an X for a second. Is 0.32. So R is 2/5. Beautiful. Okay, and if you put 0.4, I'm not mad at it, but 2/5 is also pretty, okay? All All right, so it says write an explicit rule for the nth term. You need your first term, got it, and you also have your ratio. So that is a sub n is equal to first term, which is 12.5 times my ratio, which is either 2/5 or 0.4. I do not care. To the n minus 1 power. The end. So it is less work than writing an arithmetic rule because it is like already simplified. You don't have to distribute it and combine like terms or anything like that like you do with arithmetic. Next is find the eighth term, so we need a sub 8. So we have 12.5 times 2/5 to the 8 minus 1 power, which is the 7th power. So we're just going to use our calculator to get that answer. We're going to do 12.5 parentheses 2 divided by 5 or 0.4 to the 7th power. Enter. And your answer is a sub 8 is 0.02048. Okay, and that is an exact answer. It's not rounded. A lot more numbers can fit on the calculator. If you wanted to write it as a fraction, you could also do that. You could hit math, enter, enter, and it tells you that it is 64 over 3125, which is also an acceptable answer. This problem had decimals in it, so I don't mind that there's a decimal answer. Okay, let's move on to another one. It says one term of a geometric sequence is a sub 4 is 3, so I'm telling you the fourth term is 3. The common ratio is 3. Write an explicit rule for the nth term of the sequence. So once again, to write an explicit rule for it's telling me it's geometric. Geometric sequences, I need the first term and I need the common ratio. So I have r is 3, but I don't have the first term. So what we're going to do is we are going to figure out what the first term is using our formula. So our formula, once again, which is not provided for you, is a sub 1 equals a sub n is equal to a sub 1 times r to the n minus 1 power. So what we're going to do is we're going to plug in 3 for r, and then we know our fourth term is 3, so we're going to plug in 4 for n. Try to write that small there. And we're going to say that a sub n is 3. Okay, so what we get is 3. So let's go ahead and do that. So we're going to say we get 3 when we plug this in. Trying to figure out what our first term is, and that's when we multiply it by 3 to the plug in 4 for n minus 1, which is third power. All right, now we're going to clean this up so we can figure out what a sub 1 is. So we have 3 equals a sub 1 times 3 to the third power is 27. Divide both sides by 27. And we get a sub 1 is equal to, simplify that fraction, 3 goes into itself once, 3 goes into 27 9 times. So now we know our first term and we can write our rule. A sub n is equal to a sub 1, which is 1/9, times r, which is 3, to the n minus 1 power. And there's your rule. All right, the last type of problem, and like if you look at the rest of it, it's all just practice. So what I'm going to do after this problem is I'm going to stop the video, and then you can just check your answers with the key in Schoology, okay? This one here says 2 terms of a geometric sequence are, the second term's -4 and the sixth term's -1024. Write an explicit rule for the nth term. So I am given 2 terms, not the first term, not the ratio. So I have to figure out what the first term is, and I have to figure out what the ratio is. So I know that my formula, once again, is a sub n is equal to a sub 1 times r to the n minus 1. And I am given, when I plug in 2 for n, I get an output of -4. When I plug in 6 for n, I get an output of -1024. So I have 2 equations that leave me with 2 variables. So what we're going to do is we're going to write a system to solve this. We cannot write 2 ordered pairs and write an equation of a line. This is not an equation of a line. This is an exponential function, all right? So let's write our system. So I'm going to say when I plug in 2 for n, I get an output of -4. So I have -4 is equal to a sub 1 times r to the, put a little dot there, times r to the, and then I'm plugging in 2 for n. So 2 minus 1 is the first power. Then I'm going to do the same thing for another equation. So I'm going to say when I plug in 6 for n, I get -1024 is equal to a sub 1 times r to the, and I plug in 6, so 6 minus 1 is 5. All right, so here's your system. It's got 2 equations, 2 variables. Your 2 variables are a sub 1 and r. So What you're going to use here is you cannot use elimination, because elimination is when you have two terms separated by addition or subtraction. So there would have to be addition or subtraction right here, which it's not. So we have to use substitution. When we want to use substitution, you have to have a variable solve for. So what we're going to do is we are going to solve the first equation for one of the variables. And I always just solve the first equation for a sub 1. Okay, you can solve the second equation for a sub 1, but I never do that. So I'm going to solve the first equation for a sub 1. In order to do that, I'm going to divide both sides by r to the first power. Right, so divide by r to the first, divide by r to the first. So now those cancel. And I have a sub 1 is equal to negative 4 over r to the first power. And now you can use substitution to solve for one of your variables. So I'm going to take this, and I'm going to replace a sub 1 with that. So I have negative 1024 is equal to, instead of writing a sub 1, I'm going to write negative 4 over r to the first power times, and then we have r to the fifth power. All right, now you're going to simplify this equation. So there's an r to the first power in the numerator, which cancels with one of the r's in the denominator, or sorry, there's an r to the first power in the denominator, which cancels with one of the r's in the numerator, so you have 4 left. So now you have negative 1024 is equal to negative 4 times r to the fourth power. Now I want to get rid of that coefficient of negative 4, so I'm going to divide both sides by negative 4. So I have 1024 divided by negative 4. You can use your calculator or mental math, so that's 512, 256 is equal to r to the fourth power. And now I need to solve by getting rid of that fourth power. Okay, to get rid of the fourth power, you fourth root or bring to the 1/4 power. Technically, there's 2 answers to this, because when we fourth root, we have to do plus or minus, but it just says write an equation. It doesn't say write all the equations. So I'm not going to do plus or minus. It's just a personal preference, okay? So once again, you can do fourth root, or you can do 1/4 power. I'm going to show you both in your calculator. So fourth root is just square rooting twice. So you can say the square root of 256 is 16. The square root of 16 is 4. The answer is 4. Or you can just use guess and check. You can say, is it 3 to the 4th power is 256? No. Is it 4 to the 4th power is 256? Yes. But there's another way to do that, which is actually doing fourth root. To do fourth root, you hit math. The 5th option down is any root, okay? So if you choose that, actually I'll make a mistake right now. I'll choose that. It's taking, no, I'm not going to do it the wrong way. So if I want to do fourth root, I have to hit 4 first to do fourth root. Then I hit math. Option number 5 is any root. So what it'll do, it'll change it to fourth root, okay? And then I hit the 256, and it says it's 4. Or another thing is that fourth root is the same thing as the 1/4 power. So you could do 256 to the 1/4 power. 1 divided by 4. And it'll give you 4. So after showing you 8,000 ways to do that, r is 4. All right, now I have r is 4. I still need to know what a sub 1 is. So I'm going to go back to this right here that tells me that a sub 1 is equal to negative 4 divided by r to the first power. R to the first power is 4, because this is what r was, right? And then we get that is negative 1. So a sub 1 is negative 1. So finally, after that over explanation, we have a sub n is equal to a sub 1, which is negative 1, times r, which is 4, to the n minus 1 power. And there you go. All right, so now you can go ahead and stop the video and go ahead and check your answers that I will put on Schoology for all of these.